Let us continue slides now. So now we are going to see some properties of the probability, right? So sum of probabilities of all event of an experiment equal to 1. For example, suppose if you are tossing the coin, only one coin, so what are the possible outcomes? Head and tail. So they are the two events. So what is the probability of getting head? Definitely 1 by 2. And similarly, what is the probability of getting tail? So that also 1 by 2. So if you add these two probabilities, 1 by 2 plus 1 by 2, so what about the result? The result is nothing but 1. Right? In the similar way, suppose if you are throwing a die, so what are the possible cases? 6 numbers, 1 to 6 numbers. Right? So what is the probability of getting the number 1 alone? So 1 by 6, because only one number is there, so 1 by 6. What is the probability of getting the number 2? That also 1 by 6, because only 1, 2 is there. What is the probability of getting number 3? That also 1 by 6. And similarly, the probability of getting number 4, 5, 6, everything 1 by 6. Right? Now, if you add all the probabilities, so 1 by 6 plus 1 by 6 plus 1 by 6, how many 1 by 6s will come? So 6 events are there, so 6 1 by 6 will come. If we add everything, we will get 6 by 6, the answer is 1. So, if you find the probabilities of all the events of an experiment, definitely after simplification, that will be 1. That is the one important property. Okay. And from that you can write or create or derive one formula P of E plus P of E bar equal to 1. So already I said E is nothing but event and E bar is nothing but opposite event of E. That is the meaning E bar. Okay. For example, if you are tossing only one coin means if you are expecting the head, so getting head means the tail is nothing but your E bar. Okay. In the similar way, if you are throwing a die, right? So the event is that the question is what is the probability of getting odd numbers? Okay, what is the probability of getting odd numbers? So if we call that odd numbers as E1, E means, and E bar is nothing but the remaining set of numbers. That is the set of even numbers. Okay, so E means it is one of the set of the particular experiment, and E bar is nothing but another set of the particular experiment. Okay, suppose one more thing. Suppose 1, 2 and 3. Suppose let us take, this is one of the sample space for example. So 3 numbers are there. Let us consider, let us ask one question now. What is the probability of getting the number 2 alone? So what is the probability? So only 1, 2 is there out of 3 numbers. So 1 by 3 is the answer. That let us call this getting 2 as E means the remaining set of numbers, that is 1, 3. So that is under E bar. So if you add these two, we'll get 1. Okay, that is the formula. And look at the next one. Probability of an impossible event is 0. For example, if you tossing a coin or if you throwing a die, so how many possible outcomes are there? 1 to 6 numbers. Suppose if the question is like this, what is the probability of getting the number 7 when throwing a die? Is it possible? So definitely 7 is not possible when you are throwing die, because at most 6 numbers only there. Okay, so it is not possible. So the answer is 0. So the probability of an impossible event is 0 always. Okay. And look at the next problem, that is property, limitation of the probability of an event. So if you take the probability means the maximum probability is 1. That is the total probability of an experiment is 1. And the minimum numerical value of the probability is 0. Therefore, always the probability, the limitation of the probability is nothing but lies between 0 and 1. That is 0 less than or equal to P of E less than or equal to 1. So that is very important property in probability. Okay, these 3 are very important properties, right? So sum of the probability of an experiment 1, and the probability of an impossible event is 0, and the limitation of probability is 0 less than or equal to P of E less than or equal to 1. So it means the probability of any event may be 0 or definitely less than or equal to 1. Okay. So look at the next example. So a bag contains 1 to 10 numbers. So what is the probability of getting even numbers, odd numbers, right? So total 10 numbers are there. So sample space is nothing but 10. Okay. And first question is nothing but even numbers. Okay. And before that, we can find out n of s. N of s is nothing but, so totally 10 numbers are there inside the bracket. So 10. And next we are going to define the event, that is question. So the question, first question is nothing but even numbers, right? So that E1 equal to the event of getting even numbers. So out of 10 numbers, what are the even numbers? So 2, 4, 6, 8 and 10. Right. Next we are going to count the elements inside the bracket. So 5. So n of E1 equal to 5. So what is the probability? So we can divide this one by this one. So 5 by 10. So 5 by 10 is nothing but 1 by 2. Similarly, the next subdivision, odd numbers. Okay. So let us consider this event as E2. So E2 equal to the event of getting odd numbers. So odd numbers are 1, 3, 5, 7 and 9. So n of E1, E2 is nothing but 5. And probability is 5 divided by 10 equal to 1 by 2. Right. And next very important examples, that is or experiments under the probability is playing cards. That is very important experiment in probability. Okay, so most of the questions they are asking under that kind of experiment only in our board exams, right? So first we can know about the playing cards, how many cards are there in each variety. Okay, look at that. So totally how many playing cards are there means 52 playing cards are there. So we can split that 52, all the 52 playing cards into 4 types of cards. 4 different types of cards are there. Okay, what they are? So these are the 4 different types of 52 cards. Okay, so the first one is diamond, second one clever, and third one heart in, that's our heart, and fourth one spade. So these 4 different types of cards are there in 52 cards. Okay, right. In each one, in each variety, okay, in each variety, how many black cards are there? So 26 black cards, and also listen here. So totally 4. Okay, 4 types of cards are there. In that you can classify the colors 26 plus 26, that is black and also red. Okay, so 26 black cards are there and 26 red cards are there. Okay, in that, so these 2 types are always black. Okay, that is clever and spade cards, and these 2 cards, that is diamond and heart, is the cards of red. Okay, so we can classify 52 cards according to the colors. So 26 plus 26, so 26 black and 26 red. Okay, and numbers printed on the cards also 2 to 10 numbers printed on the cards. Okay, and the remaining, actually according to the color we can classify 26 plus 26, but each variety, that means 4 types of cards are there already I said, that is these kind of cards only, that is diamond, heart, spade and clever. But in each variety how many cards are there? So 13 cards available in each of the varieties, 1 3, so 13 cards available. These 13 cards can be classified like this. Okay, so first 2 to 10 numbers printed on the card itself. Okay, so totally 9, so 9 cards printed with the number. And what about the remaining 4 cards? The remaining 4 cards is nothing but ace, king, jack and queen. So totally 13 cards now. Okay, so these are the images of ace, king, jack and queen. So totally 13 cards will come. Okay, so how can we split? Totally 52 cards are there. How can we split 52 cards now? According to the color, 26 plus 26, 26 black, 26 red, and according to the type, 4 types. So one is diamond, then clever, then heart, then spade. In each type, how many cards are there? So 13 cards are there. In 13, 9 cards are with a printed format, that is from 2 to 10. The numbers 2, 3, 4 up to 10 numbers are there. And what about the remaining 4 cards? The remaining 4 cards are ace, king, jack and queen. So these are the images of the 4 cards. So these are the classification of playing cards. Okay, that classification is very important. Okay, right. Now look at the examples. So one card is drawn from a well shuffled deck of 52 cards. Calculate the probability that the card will be, that means 52 cards are there. Suppose we are going to draw one card from out of 52 cards. So what is the probability that the card will be? So these kind of cards. So ace, jack, king, queen, black, red, 5, face. So these are all everything questions only. So how many events are there here? So events is nothing but here 12 events are there. Okay. So here which one experiment? So experiment is nothing but that is 52 chords. Out of 52 chords, we are going to take one chord from that. Okay, so this is nothing but experiment. And what are the events? So these everything 12 chords, that is 12. These 12 are events here. So you can define E1, E2 up to E12. Okay, look at the solution now. Solution. So total is nothing but 52 chords. So n of s 52. And now we are going to define all the events by one. Okay, so total 12 questions are there. So 12 events we need, that is up to E12. I took the first event as E1. So what is E1? The probability of getting, or the event of getting ace card. So that is our event. So how many ace cards are there? So in each variety 4 different cards are available, I said, that is ace, jack, king, queen. So in all the cases, that is in diamond also ace is there, heart in also ace is there, and clever also ace is there, and that is in spade also ace is there. So totally 4 ace will come. So n of E1 equal to 4. So we have to divide this answer by this answer, that is our probability. So 4 by 52 equal to, if you simplify this, we get 1 by 13. That is here one time, and here 13 times, right, with the fourth table. Okay, that is the fourth table. And next event, what is the next event? Getting jack. So let E2 be the event of getting jack card. So equal to n of E2 4. So the answer is 4 by 52. So 1 by 13. So, and what about the next one? So in the remaining case, that is remaining 10 cases are there. So what about the probability of getting king? So this king also, so the king also 4 kings are there. So 4 by 52. So queen 4 by 52. And what about black? How many black cards are available? 26. So the answer is 26 by 52. And what about red? So red also 52 is 26 are there. So 26 by 52. And number 5. How many number 5s are there? So in each variety, the number 5 printed on the card is there. Okay. So in diamond 5 is there, and spade 5 is there, and clever 5 is there, and heart 5 also there. So totally, yes, 4 by 52. Similarly, face cards. So face cards means that is these 4 cards, that is ace, king, jack, queen. These 4 cards having face on the card itself. So face card means it represents these 4 cards only. So what is the probability now? So 4 cards are there with a face. Okay. So in each, that is in, for example, if you take diamond means 4 cards are there. If you take spade means 4 cards are there. And if you take clever means 4 cards are there. And if you take spade means 4 cards are there. In each variety 4 cards are face cards. Totally now how much cards? 16. 4 into 4, 16. So the answer is 16 by 52. Right? That is the answer for the 8th one, face cards. Non-face cards means the remaining cards everything non-face cards. So 16 cards are face cards. And what about the remaining? So 52 minus 16. So how much? 36. So the 36 are non-face cards. So the answer is 36 by 52. And similarly diamond. How many diamonds are there? So diamond is one of the variety of the card. So in each variety 30 cards I said. So the answer is 13 by 52. And heart also one of the variety. So that also 13 by 52. And spade 13 by 52. Clever 13 by 52. And finally not be an as. Okay, in ace card, how many ace cards are there? 4 ace cards are there already we found. So not be an ace. So we have to subtract the number of aces from 52. So how much? So 52 minus 4, 48. So the answer for the last one is 48 by 52. Right? So that is the procedure for finding the probability of any experiment. Okay. So here I completed first 2 with the uh, properties with the necessary steps. So complete the remaining also with the necessary steps.